Hello everyone. Let's continue our discussion in motion along straight line, which is one-dimensional motion. We started motion along straight line with uniform acceleration. So when acceleration is uniform, we have equations of motion that we can use to solve problems related to velocity, acceleration, displacement, distance. So the equations of motion are V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS, S is equal to V plus U into T by 2, S is equal to Vt minus half AT square. So let's apply these equations in vertical motion under gravity. So that is a straight line which is vertical straight line, and the motion is under gravity. So how we will use these equations for motion under gravity? So motion under gravity, what is that? The only force acting is weight of a body, which is mg. So net force is equal to mg, and net force is equal to mass into acceleration. So we have acceleration is equal to g. Acceleration is equal to g. G is known as acceleration due to gravity. Acceleration due to gravity. So we have, suppose this object. Now this object, when I release this object from rest, it is falling downward. It is falling downward. Why? Because the weight is acting downward. If we ignore the air resistance, the air in this room is also exerting force in the upward direction, that is known as air resistance or air friction. If we ignore that, if we neglect air friction, so the only force acting on this falling object is weight. So the weight is acting downward, so we have force is equal to mg. So we know that the force is ma, so ma is equal to mg, so a is equal to g. So that is known as acceleration due to gravity. Acceleration is there, we know that we observe this, that the initial velocity is 0, and as it is falling down, the speed is increasing, so velocity is also increasing, so it is accelerating. And what is the reason for that acceleration? Gravity. So that's why we call that acceleration as acceleration due to gravity. Direction is downward because force is downward. Force is downward, so G value is downward. So acceleration is basically minus G when we consider the vector form of acceleration. Minus G. Minus sign shows it is downward. So these equations of motion we have to modify actually. Downward direction is negative, upward direction is positive. So when velocity is upward, we will consider positive. When velocity is downward, we consider negative. For example, the same object, if I throw this upward like this, it is thrown upward. When it is thrown upward, the velocity is positive. When it is coming down, the velocity is negative. When it is thrown upward, the displacement is positive. And when it is coming down, the displacement is negative. So we will use sign convention for initial velocity, final velocity, displacement, and acceleration. So these quantities are vector quantities. So plus and minus we have to take care. Upward is positive, downward is negative. So we have acceleration also negative. So these equations of motion will become V is equal to U minus GT, S is equal to ut minus half gt square, and v square minus u square is equal to 2 into minus g into s. And the g value is 9.8 meter per second square. Sometimes we take it as 10 meter per second square. G is equal to 10 meter per second square. So let's start solving questions related to motion under gravity. Let's start from very basic. How do we observe motion under gravity? Suppose we have some object with us. Like for example, I have this object. I will throw this object in vertically upward direction. Let's see what happens. So it is going up and coming down. If you observe its motion, it is going up, so it is covering some distance in the upward direction. We call it height. So the maximum height, maybe it is coming up to here, then again it is returning. So that is the maximum height. Same height it is falling down. One more thing you observe, as it is falling, as it is going up, when it is going up, the velocity is decreasing. See, when it is going up, the velocity is decreasing, and when it is coming down, the velocity is increasing. And topmost point velocity is 0. Topmost point velocity is 0. So let's consider its upward motion. A ball is thrown up with velocity u. Thrown up with velocity u. So this u can be plus 1 meter per second, 2 meter per second, 3 meter per second, 10 meter per second. It will be positive because it is thrown up. So initial velocity is positive. Find maximum height attained. And second question, also find time to reach maximum height. How much time it will take to reach the maximum height point, that is on the topmost point. Topmost point or the highest point. Topmost point or the highest point. So topmost point, we know the velocity is 0. So final velocity will be 0. If we draw the diagram representing this type of motion, so we have this ball, it is thrown up with velocity u, and at topmost point the velocity will become 0. So it is covering height h. So the displacement is equal to h. Displacement is h because it is upward. Displacement is upward, so it is positive. Initial velocity is u, final velocity is 0. Initial velocity is u. Acceleration is minus g. We can take it as minus 9.8 or minus 10 also. So we will use v square minus u square is equal to 2as. So 0 square minus u square is equal to 2 into minus g into h. So minus minus cancelled. So we will get h is equal to u square by 2g. This is the formula for maximum height attained when ball is thrown upward with velocity u. So suppose if it is thrown with velocity 1 meter per second, so how much height it will go? Let's calculate this using this formula u square by 2g. If it is thrown with velocity 1 meter per second, so final velocity will be 0. So the h will be equal to u square by 2g, so that is 1 square by 2 into 10, so that is 1 by 20 meter, 1 by 20 meter. If it is thrown with some greater speed, let's say 10 meter per second, so h will be equal to u square by 2g, so that is 100 by 20, this will become 5 meter. So it is going to more height, greater height. When it is thrown with 1 meter per second, it is going only 0.1 by 2, which is 0.05 meter. And when it is thrown with 10 meter per second, it is going to maximum height 5 meter. So more speed means more height it will attain. Now let's calculate how much time it will take to reach topmost point. So we will use v is equal to u plus at. Final velocity is 0 at the topmost point. Initial velocity is u. Acceleration is minus g. Time is t. So gt is equal to u. So t is equal to u by g. This is the time during upward motion. This is also known as time of ascent. Ascent means going upward. Going upward. Ascent means going upward. So these two questions we have solved. Now, what happens if the same object is now coming down? We know that if any object is thrown up like this, if any object is thrown up, it will come down. So it is going up and then coming down. So this is known as ascent, this is known as descent. So if air friction is ignored, so we can prove that time to reach the topmost point is equal to time to come back. If it is going t seconds to go to the topmost point, it will take another t seconds to come back to the same point, same level. So this is known as time of ascent. So what is the time of descent? Time of descent will be same if air friction or air resistance is ignored. If air resistance is ignored or neglected, time of descent will be same as time of ascent. So the going time, it is taking u by g seconds. Coming time also it is taking u by g seconds. So total time of flight, total time of flight is equal to u by g plus u by g, that is equal to 2u by g. Total time of flight is 2u by g. This is another formula for us. So if we know the velocity u, we can calculate the total time of flight like this. Again, I am catching the same object. What is the total time of flight? Going and coming. So let's solve another question. I will give total time of flight and what will be the velocity of throw. A ball is thrown up with velocity u. It takes time 4 seconds to come back to the same level, find u and maximum height. So we will use the formula directly. The time of flight is 4 seconds, means ascent and descent both included. So we know the formula for that 2u by g. 2u by g is given as 4 seconds. So 2 into u by 10 is equal to 4. So u will be equal to 40 by 2, that is 20 meter per second. And we know that the height formula h is equal to u square by 2g. So that is 20 square by 20. So the maximum height it will attain is 20 meter. Let's do some tricky questions. Half of maximum height. Suppose the ball is thrown from this point, this level, you can call it ground level, and up to this point the ball is reaching. So here velocity will be 0. So this is known as maximum height. Maximum height level. We can also call it topmost point. Topmost point. Half of maximum height will be midway. So midpoint between these 2 points. For example, if the point of throw or point of projection is A and the topmost point is B, so the midpoint C is the half of maximum height. So this maximum height will be h by 2. Half of maximum height is h by 2 and the maximum height is h. So the question says, what is the velocity at half of maximum height and what is the time taken to reach half of maximum height? Let's do it. So I will write what we are going to find here. First question is find velocity at half of maximum height. We can solve this using two methods. One method is kinematics method, another method is energy conservation, that is mechanical energy conservation in chapter work power energy. So we will use kinematics method. First, let's use v square minus u square is equal to 2as one time I am using it from A to B. Second time I am using it from C to B. Why A to B and C to B? Because the calculation will be easier. Because in both the cases, A to B and C to B, final velocity is 0. So our calculation will be easier. So A to B, I am using v square minus u square is equal to 2as. So 0 square minus u square is equal to 2a into s, which is h. And C to B, it is 0 square minus v1 square is equal to 2a h by 2. Because C to B, the displacement is h by 2. Now divide these two equations. So we get minus u square by minus v1 square is equal to 2ah by 2ah by 2. So this will be u square minus v1 square is equal to 2. So u square by 2 is equal to v1 square. So we have square root of u square by, take square root on both sides. So u by root 2 is equal to v1. So this is the velocity at half the maximum height. Velocity at half the maximum height, which is u by root 2. u by root 2 can be written as 0.707 u, because 1 by root 2 value is 0.707. So if somebody is saying, if ball is thrown with velocity u, it is reaching the topmost point at B. So at half the maximum height, the velocity will be half of u. So that is wrong. It is not half. Velocity is not u by 2. The velocity is u by root 2. Remember. Now how to find the time taken? Time taken to reach half of maximum height. Second question, time to reach half of maximum height. So for that we will use V is equal to U plus AT from A to C. A to C. Time to reach half of maximum height. This is the point of throw and this is the middle point, middle height, or halfway during the ascent. So V is equal to U plus AT. Now velocity at C. So this is at C and U is at A. So we have U by root 2 is equal to U minus GT, because acceleration is minus G. So GT is equal to U minus U by root 2. So GT is equal to U is taken common into 1 minus 1 by root 2. So we have T is equal to U by G into root 2 minus 1 by root 2, or numerically we can also say it is U by G into 1 minus 0.7, 1 by root 2, approximately I am taking 0.7. So this is 0.3 times U by G, 0.3 times U by G. Now what is U by G here? U by G is the time of ascent. This is time of ascent, time of ascent. So this is 0.3 times time of ascent. So if somebody is saying at the mid height it will take half the time, so that is wrong. No, it is taking 0.3 times the time of ascent. Suppose it is going upward and it is taking 1 second. So at half the height it will take 0.3 second, and remaining 0.7 second it will take to cover the remaining height. So how to find the time to cover remaining height? So this is the topmost point, and this is the ground level. It is thrown with velocity u. So this is the mid level. So we have found time to reach half of maximum height is u by g into 1 minus 1 by root 2. We can call it T1. So the remaining height will be covered in time T2. Now T2 will be equal to time of ascent minus T1. To cover half of maximum height, it is taking u by g 1 minus 1 by root 2. So remaining time it will take time of ascent minus T1. So that is u by g minus u by g into 1 minus 1 by root 2. So this is u by g minus u by g plus u by g root 2. U by g cancel. So T2 is equal to u by g root 2. That is equal to 0.707 u by g, or approximately we can consider 0.7 u by g. So suppose we can memorize this by taking an example. If time of ascent is 1 second, then time to reach maximum height, then time to reach half of maximum height, half of maximum height will be 1 minus 1 by root 2 second, and time to cover remaining height means the remaining h by 2 height, it will take 1 by root 2 seconds. So roughly time to reach maximum height is 1 second, and time to reach half of maximum height is roughly 0.3 second, and remaining height will be covered in 0.7 second approximately. So this is what the upward motion. Now let's talk about downward motion. So when it is downward motion, the same object, when it is dropped, then initial velocity is 0. Now the object is dropped. It is dropped like this. Initial velocity 0. Let's consider drop of an object. We can also call it released. Released under gravity. Released under gravity. So when something is released under gravity, so what is the initial velocity? Let's understand this by taking two examples. Something is released under gravity. What do you mean by this? Can I say the initial velocity is 0? Yes, I can say. For example, I am holding this object. Right now, I am also at rest. So this object is also at rest. So the initial velocity of this object will be 0. If I release it now, like this, initial velocity 0. Now imagine I am sitting in a balloon. Balloon is going upward, and I am holding this object. I am sitting in a balloon. Balloon is going upward, and I am holding this object. So when I release it like this, the initial velocity will not be 0. The initial velocity will be same as balloon. So let's understand these two situations. What do you mean by released? Released means it is detached, and the force acting is only gravitational force. If ball is released from building or from stationary person, a person is holding the ball and the ball is released, so initial velocity will be taken as 0. Then u will be taken as 0. If ball is released from balloon which is moving upward, with some velocity, say v1, balloon is moving upward. So suppose this is the balloon, so there is a basket here, this is the basket, and the person is standing on this balloon, and the person is holding a ball. This is the ball it is holding. So ball is holding like this. The person is moving upward because person is sitting in a basket which is connected with a balloon. So balloon is going upward with velocity v1. Now imagine I am the person holding the ball in a balloon. So the person is moving upward with what velocity? V1. Now I am holding this object and then it is released. So the velocity will not be 0, it will be V1 when seen from ground. So when seen from ground, initial velocity will be V1, same as balloon, means the frame of reference is ground or observer is on ground. So that is known as ground observer. So when you see from ground, the velocity of the ball will be V1 when it is released. So let's do two questions. In first question, I will consider the ball is released from building. So initial velocity will be 0. And second question, I will consider ball is released from a balloon which is going upward with velocity v1. So topic is ball is released from top of building. We can call it tower. So initial velocity will be 0. So after t seconds, how much distance it will cover? So we can use s is equal to ut plus half at square. So displacement will be 0 minus half gt square. The displacement is negative because it is falling down. So it is falling down like this. So displacement is negative. So in 1 second, how much it will cover? It will cover minus 1 by 2 into 10 into 1 square, which is minus 5 meter in first second. In first second. And it will cover minus 1 by 2 into 10 into 2 square in first 2 seconds. First 2 seconds it will cover. And it will cover minus half into 10 into 3 square in first 3 seconds, and so on. If you draw the diagram, it will look like this. In first second, it is covering g by 2, and in first 2 second it is covering 4 by 2, that is minus g, you can say 4g by 2, and in first 3 seconds it is covering 9g by 2. So this is the displacement in first second, this is the displacement in first 2 seconds, and this is the displacement in first 3 seconds. So what is the displacement in second? This is the displacement in second. So second, how much it is covering? 4g by 2 minus g by 2, so it will be 3g by 2. So A to B is the displacement in first second, A to C is the displacement in second, and C to D will be the displacement in third second. So in third second, how much it is covering? So this is third second. So in third second, it is covering 9g by 2 minus 4g by 2, that is 5g by 2. So we call it nth second. Nth second is one of the important topic in motion along a straight line with constant acceleration. So when acceleration is constant, what do you mean by nth second? Nth second means displacement in n seconds minus displacement in n minus 1 second. For example, horizontally, if total displacement in n second is this much and total displacement in n minus 1 second is this much, so the displacement in nth second will be this much. This is known as Snth. Snth. So we can make a formula for this. Snth is equal to Sn minus Sn minus 1. Now Sn means the time taken will be n seconds, and suppose the initial velocity is u and acceleration is a. So Sn will be un plus half a n square, then minus Sn minus 1 will be u into n minus 1 plus half a into n minus 1 square. If we solve this, we'll get Snth is equal to u plus a by 2 into 2n minus 1. Snth is equal to u plus a by 2 into 2n minus 1. So let's go back to previous situation, which is motion under gravity. So object is released from rest. So in first second, how much it will cover? G by 2. In second it will cover 3g by 2. In third second it will cover 5g by 2. So let's find these answers using this formula, u plus a by 2, 2n minus 1. So in first second it will cover, u is 0, so 0 plus a by 2 into 2n minus 1, so 2 into 1 minus 1, so that is equal to g by 2 into 1, so g by 2. In second it will cover 0 plus g by 2 into 2 into 2 minus 1, so that is equal to g by 2 into 3. And in third second it will cover 0 plus g by 2 into 2 into 3 minus 1, which is 5g by 2 or g by 2 into 5. This is known as nth second. Let's go back to the situation. So in the drop situation, when it is dropped from the top of a building, the initial velocity is 0. Then how much height it will cover? That also we can find. If initial velocity is 0 and we know that the final velocity, then we can use v square minus u square is equal to 2as. And suppose the height is given, from what height it is released, then we can find the velocity of strike. The same formula we can use that we have studied in the time of ascent. During ascent, so suppose it is released from velocity 0, now it is coming down, so it will hit the ground with velocity v if height is h. So we will use v square minus 0 square is equal to 2as. Now s is minus h, it is going down, so v square is equal to 2gh, so v is equal to square root of 2gh, and it is negative. It will be negative because when it is hitting the ground, this velocity is downward, so we have to take it as negative. Very important, this concept. So we will put one minus sign here. So velocity is minus square root of 2gh. Speed, when we say speed, then we can take its magnitude square root of 2gh. So let's take one example. A ball released from 10 meter height. Find velocity of strike. So we will use V is equal to minus square root of 2gh. It will be minus square root of 2 into 10 into 10. So that will be minus root 2 into 10 minus 10 root 2 meter per second. This is the velocity of strike. Then we can also find time of fall. Time of fall. So time of fall is same as time of ascent. So it will be same as u by g. Or we can use s is equal to half gt square. So 2h by g is equal to t square. So t will be equal to square root of 2h by g. This is the time of fall. So in this question, how much is the time of fall? It will be equal to 2 by 10 into height, which is 10. 10 cancels. So answer is root 2 seconds. It will take root 2 second to fall through height of 10 meter. Next, we will discuss last second. Last second of fall. What do you mean by last second of fall? Suppose let time of fall is 1 second. Time of fall is 1 second. Then last second is 1 second. Last second is first second. If time of fall is 2 seconds, then last second is second second. Last second is second second. Similarly, if time of fall is 3 seconds, then last second is third second. If time of fall is n seconds, if time of fall is n seconds, then last second will be nth second. Then last second is nth second. So we have to understand what do you mean by last second. Let's do one question based on last second. A ball takes 2 seconds to reach ground. When released from some height, find distance covered in last second. So to solve this question, we can use ascent formula. Ascent formula is equal to u plus a by 2 into 2n minus 1. So u is 0. When something is released, we are considering it is released from top of building. So it is taking 2 seconds to fall to the ground. So we have ascent is equal to a by 2, 2n minus 1. So distance they are talking about, so it will be magnitude only. So we can use g by 2 into 2n minus 1. Displacement will be negative, but distance is positive. Now total time taken is 2 seconds. So here last second is second second. So basically we have to find displacement in second second or distance in second second, which is equal to g by 2, which is 10 by 2 into 2 into 2 minus 1. So that is 10 by 2 into 4 minus 1. So 10 by 2 into 3 So that is 15 meter. Displacement in last second is minus 15 meter. Distance in last second is 15 meter. Next question.